Hello, all right, welcome back. Frictional forces. It's a form of application of forces that we're going to be talking about here. The book, obviously, is our book that we've been using, Physics of Everyday Phenomena by W. Thomas Griffith. That's where our examples will be coming out of, okay? So here we'll have on the page 71, figure 4.15. We see a picture of a chair, okay? A chair. Okay? Somebody's applying a force in that direction. Applying a force. It has a letter P there, so I'm going to put F sub P, which indicates that it's a pushing force. A pushing force. And we have weight pulling this thing down. Its natural weight is pushing onto the surface that it's laying on, and subsequently, reactively, due to Newton's which law? Third law. For every action, there's an equal opposite reaction. There is a normal force pushing back from the surface of the surface that this chair is sitting on, back up onto the chair. Okay, F sub W for weight, F sub N for normal force. Weight comes from the chair and normal force comes from the surface, okay? So when you have this, you see one more arrow on the book, okay? What do you have? When you push in one direction for an object, you end up getting a frictional force in the opposite direction, okay? So you push something across the floor, it's going to resist that movement, okay? That resistance of movement is due to the nature of the two different materials that you're moving across. Okay, so maybe it's like the wooden feet of the chair against the linoleum tile that you're pushing across. Okay, and all two surfaces in the world have coefficients of friction. Okay, and again, friction acts opposite to the direction of movement. Okay, so this is an applied force here. This is somebody pushing this chair. But what about something that's just naturally falling? Okay, what about something that's naturally falling on an inclined plane? Okay, whoops, too much. We have an inclined plane, and this block wants to naturally fall down here, okay? It just wants to slide on down. Well, if it's wanting to slide down, there is a force in the opposite direction wanting to hold it back, and that would be the frictional force. Okay, that example is not in the book, but I just wanted to show you an example that does not include an applied force, okay? So are there any more? Yes, there's another example here in the book I'll give to you. Its meaning. So it is figure right next to our previous one, figure 4.14, and it shows a picture of a car, okay, in movement. Shows a picture of a car in movement. Very poor car here. Moving forward. And its wheels are pushing back against the ground. That is our applied force. Okay? But something is pushing the opposite direction. Something is pushing that way. All right, so with every force that we have here that we're pushing against, we have a frictional force pushing in the opposite direction. Now, if we did not have that frictional force was zero, the car would just be sliding right there. I'm sure some of you have experienced that driving on ice, right? Well, that's what would happen. Our frictional force would go to zero, all right? That's not an ideal driving condition. Anyway, those are a couple of examples of frictional force. Thank you very much for watching, and stay tuned. Oh, just as a summary, frictional force is the force that acts opposite to the direction of movement. All right, thank you, and have a great day. Look forward to the next